Imagine that you're holding two identical particles, like two playing cards perfectly matched in every way. Now imagine sending one of them across the galaxy while keeping the other close. As impossible as it seems, any action you take on the card in your hand instantly affects the card billions of light years away. Welcome to the bizarre, almost magical world of quantum entanglement, a phenomenon so strange that Einstein himself called it spooky action at a distance. But what is quantum entanglement, really? How can two particles remain connected across vast distances without any physical link? And could this mysterious connection help us unlock secrets about the universe, perhaps even enabling instant communication or unraveling the mysteries of space-time itself? What is quantum entanglement? To understand quantum entanglement, we have to start with quantum mechanics, the science of the very small. In the quantum world, particles like electrons and photons don't behave like solid objects. Instead, they exist in states of probability until they are observed. A particle doesn't have a fixed location or even a definite state until it's measured. Until then, it exists in a state of superposition, where it holds all possible values simultaneously. Now, when two particles become entangled, their properties become deeply interconnected, even if they're separated by vast distances. This means that the state of one particle will directly influence the state of the other, no matter how far apart they are. If you measure one entangled particle and find it spinning up, the other, even if it's on the other side of the universe, will instantly spin down. This connection remains unbroken by time or distance, as if the particles communicate in some hidden, faster-than-light way that transcends our understanding of reality. Einstein's spooky action and the mystery of non-locality. In the early 20th century, Albert Einstein famously scoffed at the idea of entanglement, calling it spooky action at a distance. To him, the idea that two particles could be linked across vast distances was absurd and violated his theory of relativity, which says that nothing, not even information, can travel faster than light. This instantaneous connection seemed to defy all known laws of physics. Einstein proposed that there must be hidden variables, some unknown factors or particles, embedded within the quantum particles, which, if understood, would reveal that their behavior was actually predictable and governed by local, classical physics. But as experiments were conducted, most notably by physicist John Bell in the 1960s, Einstein's hidden variables theory was put to the test and ultimately disproven. Bell's theorem showed that entangled particles really do communicate in ways that seem to transcend space and time, leaving scientists with one of the greatest unsolved mysteries in quantum physics. Could quantum entanglement be the fabric of reality? As scientists continue to probe the mysteries of entanglement, some have begun to suspect that it might not just be a strange quirk of quantum mechanics but instead a fundamental building block of reality. According to recent theories, entanglement may actually shape the structure of space-time itself. In one of the most intriguing ideas of modern physics, known as ER equals EPR, a hypothesis proposed by physicists Juan Maldacena and Leonard Susskind, entangled particles are thought to be connected by tiny wormholes in space-time. If this is true, quantum entanglement could be the glue that holds the universe together, forming a network of interconnections that gives rise to the very structure of space-time. Imagine a web where every point is connected, regardless of distance. This web could potentially explain why entangled particles remain connected without violating the laws of relativity. They might be linked by invisible threads that weave together the fabric of reality itself. The mind-bending experiments. But entanglement isn't just theoretical. Physicists have observed it repeatedly in laboratory settings, and the results are both stunning and puzzling. In 2017, scientists conducted the cosmic bell test using light from distant stars to determine the properties of entangled particles. This experiment not only confirmed entanglement but also hinted that the universe itself could be choosing the state of particles through some mysterious, cosmic mechanism. Even more recently, researchers have created entangled particles that are visible to the naked eye, entangling quantum systems large enough to see. Each experiment brings us closer to answering the question, could quantum entanglement actually help us understand the nature of consciousness or even provide the basis for instant communication across space? Practical applications, quantum computing and beyond. Quantum entanglement isn't just a philosophical puzzle, it has real-world applications that could revolutionize technology. Quantum computers use entangled particles, called qubits, to process information at speeds and scales impossible for classical computers. By taking advantage of entanglement, quantum computers could solve complex problems in seconds that would take traditional computers millennia to calculate. Beyond computing, researchers are exploring quantum cryptography to create ultra-secure communication networks. Entangled particles would allow for unbreakable codes because any attempt to intercept an entangled message would immediately disrupt the state of the particles, alerting users to the breach. In the future, entangled particles could enable instant communication across space, a tantalizing prospect that would allow us to transmit information across interstellar distances without the time lag caused by light speed limitations. Could entanglement unlock teleportation? Yes, you read that right, quantum teleportation is more than a sci-fi dream. By leveraging quantum entanglement, scientists have already been able to teleport the quantum state of one particle to another particle over long distances. This isn't teleportation as we know it in science fiction, it's not matter being moved, but rather the transfer of quantum information from one particle to another instantaneously. In the future, with more advanced technology, we might be able to teleport information, data, and possibly even the quantum states of more complex systems. The quantum enigma, what does it all mean? At its heart, quantum entanglement challenges everything we thought we knew about reality. It suggests a world where information moves instantly, where particles on opposite sides of the galaxy can influence each other, and where the fabric of reality itself might be woven from invisible connections. Could these hidden connections be the key to understanding not only the universe but our very place within it? Could entanglement even hint at a kind of universal consciousness that binds all things together? For now, quantum entanglement remains one of the most profound mysteries of science, a phenomenon that defies common sense yet has been verified time and again. In a universe that seems so vast and disconnected, entanglement reveals an unseen web linking everything in ways we are only beginning to understand. And as we delve deeper into the quantum realm, we might one day unlock the secrets of reality itself, secrets that, for now, lie just beyond the reach of human comprehension.